Hello everyone. My today's topic is RMS voltage, and this is my first video which I'm going to make it. So in this video I'm going to teach you why do we want to measure RMS voltage. What is the significance of measuring RMS voltage? Especially in case of AC circuit, it won't be present in DC. So let me tell you why. First thing, let me take a DC source. Let us tell around it won't be 12 volt. I'll connect a voltmeter here. It will display 12 volt reading. This is DC source. In case of AC source, I'll connect AC power source. It will display some reading, like say 230 volt. It will display 230 volt. Now, why do multimeter measures 12 volt as a display? Internally, you must know one thing. What happened? DC source is nothing but a continuous signal, so it is a 12 volt. But in case of AC, it is not a continuous. It's a varying signal. It will vary around 1, 2, 3 like this, and just positive half cycle, negative half cycle, positive half cycle, negative half cycle. So how does you must wonder one thing, how does a multimeter display a single value but not a multiple values like this? So the multimeter which displays a single value is nothing but RMS voltage. So why did engineers prefer RMS voltage? Because of this small reason. So let me consider a small sine wave which is varying pulse like this: 1, 2, 3, 3, 2, 1, minus 1, minus 2, minus 3, minus 2, minus 1, and this is a small sine wave. So if you connect as AC source with this sine wave, it will display some value. As I said, it is a RMS value. So how to calculate this value? Since it is a continuously varying values or continuously varying signal, we need to take the average of this signal to measure. Engineers consider to take the average, but here one problem. There is a positive here and negative here. We need to eliminate the negative signal. So how to eliminate? That out of squaring it. That's the best way. And again, minus 1 square, 2 square, minus 3 square, minus 2, minus 1. So finally we will be getting result as 24 volt. So this is the squared value. We need an average. How to take an average? Just take a square root of this. We'll end up getting something 4.63 around. This is the voltage. So this is called as RMS voltage. So if you apply this power source, and you will be getting the multiplier display as 4.363 volt. This is the significance of measuring RMS voltage. So as I said, 230 volt is an RMS voltage. Till now I have explained how to calculate RMS voltage just for small signal. So in case of large signal, what should we do? That would be our question. So in that case, we'll derive some equation which is called as relation between RMS voltage and peak voltage. In this case, we know the peak voltage. We are just by adding, we have calculated the RMS voltage. But if in case of large signal, how to know peak voltage? So 230 volt is our input voltage, single phase input voltage which we daily get. So let's calculate the peak voltage for this just by deriving the equation. So this equation is relationship between RMS voltage and peak voltage. Okay, so how did I define RMS voltage? Square root of mean of, once again, how did I define RMS voltage? Square root of mean of sum of individual values of voltage value, individual voltage values, which gives us RMS voltage. Okay, now by getting the RMS voltage, we'll calculate the peak voltage. In this case, we got the 3 just by seeing the diagram. How can we calculate for 230 volt, which is our single phase input supply, domestic supply, as you all know? So let me consider a sine wave, which is 230 volt. RMS voltage is V0. That's not V0, sorry. This is peak voltage, and this RMS mean value is 230 volt, and this is time period. By definition, 0 to pi, pi to pi sec. This is interval. This is interval. By definition, what is this RMS voltage? Vrms is equal to square root of V square. This is it, V0. This is how they have defined the RMS voltage. Okay, so since earlier I told sine wave is symmetrical, 0 to pi is same, pi to 2 pi is same. So let me consider this particular interval, 0 to pi. In such a case, what should we do? Divided by 1 divided by pi, square root of 1 divided by pi, just for considering this particular interval. So we need to add the all these signals. Actually, we don't know what are the values. What should we do then? If we don't know the values, then comes a role of integration. So let me integrate from here to here, from the interval 0 to 5. We don't know the specific values for all these things. You know this? We won't know. Integrating is nothing but continuous addition. So for example, I'll give you some points like this. If you integrate, we'll get a line like this, just and this. Similarly, if you differentiate this line, you'll end up getting small particles. So integration is nothing but continuous adding or building. Differentiation is nothing but cutting the things. So we need to consider, in this case, we need to consider every single particles on the single magnitude of voltage here. In that case, we need to add it. So for addition, for continuous addition, we are integrating, and this is the practical significance of integration. Hope you know this. Hope you got to know this. Okay. For the interval 0 to pi, V0 square d omega t. Okay. V0 is nothing but Vm sine omega t. Hope you might have come across this equation frequently. So what is this Vm? Or Vm is nothing but V peak voltage. Sine omega t is sine wave, sine omega t. Expression for sine wave. This is expression for sine wave. So we're gonna substitute here. 1 divided by pi, 0 to pi, V p square or m square sum, and this sine square omega t d omega t. Okay, since this peak is a constant, this is a constant which is not a variable, so we can take out of the integration. and this is a variable quantity. So integration of sine square theta, it is not given. We don't have integration for sine square theta. Sorry, in trigonometry, what is the value for sine square theta? This is it. 1 minus cos 2 theta divided by 2. We are substituting it. Vp square divided by 0 to pi 1 minus cos 2 omega t divided by 2 d omega t. So we're gonna integrate it, and this is constant, just take it off integration. Zero to pi 1 minus cos 2 omega t d omega t. Okay, so let's split it. Omega t minus integration of 0 to pi cos 2 omega t d omega t. Integration of cos 2 theta. Integration of cos 2 theta is 1 divided by sine 2 theta, and integrate it. This is the integration formula for cos 2 theta. Vm square divided by 2 pi. When we integrate the constant omega t with the result 0 to pi 1 divided by 2 sine 2 omega t 0 to pi. Square root of Vm square divided by 2 pi pi minus 0. So again we are going to substitute it. 1 divided by 2 sine 2 pi minus sine 0. What is the value of sine 2 pi? This is 0, and this would be 0. Sine 0 is 0, and whole thing would end with 0. So Vm square divided by 2 pi into pi, cancel. Vm divided by root 2, and or Vp, sorry, I have considered as Vp, not Vm. Both of them are correct, but here I have used as Vp. So this is the relation between peak voltage and RMS voltage. So here this is 230 volt, which is RMS value. 230. We need to calculate peak voltage, as I said earlier. Peak is nothing but 230 into root 2. We'll end up with getting 325.44. So what is the significance of finding peak voltage? You might get a question. So in case of designing a rectifier circuit, we need to multiply by root 2 by considering the we need to find the peak voltage. Since rectifier is a circuit which convert AC to DC. So AC is like this, and DC is like this, continuous signal. AC signal is a variable signal, and DC signal is continuous signal. Since we are gonna convert this particular thing AC into DC, we need to find the peak voltage. Suppose you are converting input 12 volt into DC voltage. This will be RMS value. So to find the peak value, you need to multiply by root 2. In my next video, I'm gonna teach you how to design a rectifier circuit so that you come to know. Just for sake, in this video you just remember the significance of multiplying or finding the peak voltage using RMS voltage. That is, it is used in designing the rectifier circuit. Hope you understood this video, or hope you understood this concept. Thank you. Please share and subscribe my video.